Shravya, and she's going to give us a talk about behind the label glimpses from data labeling labels for AI. So Shravya is a doctoral researcher at the Center of Human-Computer Interaction Design HCID at City University of London. Her PhD work examines data annotation, work practices, paying particular attention to systemic challenges and frictions to envision and inform just, equitable features of AI. So more broadly, her research contributes to technical studies of emerging technologies in which she strives to adopt and develop a power-aware perspective. So the floor is yours, Shravya. Take it away.
Thank you so much. Thanks for having me here today. And I'm very happy to present my research, and thanks for organizing this. My name is Shravya. I'm a PhD student at City University of London. My PhD is in HCI, and I'm particularly looking at the data labeling labels involved for AI system building. I've been doing this research for a bit longer, even before the PhD since 2020. And today's talk draws on one study that I'd conducted last year in collaboration with my supervisors, both at City University of London and Ding at Google Research. I conducted this research in collaboration with Ding at Google Research last summer, and this talk draws heavily from the findings of that study. So we've all been reading and hearing a lot about AI in the news, and AI has been constantly making the headlines over the last few years, right from driverless cars to the use of AI in high stakes environment like recruiting or healthcare, and to more recently, all the news we've been seeing about generative AI systems. Uh, what is interesting about the coverage and the attention that AI has been receiving over the years is that the attention is predominantly given to the computational capabilities of these AI systems. And rarely do we see a recognition of the data and a human intensive data labeling work that is involved in training these systems, but also in supporting them. And that is going to be the focus of today's talk and is also the focus of my research. By data labeling, I refer to the human work involved in creating training data sets for AI and ML models. There's also other kinds of work that is now included within the ambit of data labeling that involves things like model validation and impersonating AI systems. Some of these I'll get into as we go ahead. So when we do see labeling making news, it's usually one of these kinds. I'm sure many of us may be aware of the Time magazine exclusive that came out a few weeks ago, which showed that Kenyan workers were involved in supporting ChatGPT and making it do better be better at its sort of conversations that it comes up with. Similarly, there have been several stories in the past that have shown that AI is not in fact fully automated. There are human beings and data workers working behind the scenes in making AI what it is. If it's not one of these stories, the other kind that we see is the one you see below, which is that AI is not just taking away jobs, but it's also creating them. And news piece is specifically in the context of India, where over the last few years, there's been quite some significant emphasis on capturing the data labeling market because globally there's been a boom in AI and subsequently a growing market for data labeling work. And India is among only several other countries that are also interested in capturing this market by offering policy deregulation and other kinds of incentives to become a sort of a front runner within this space. So within that context, I also wanted to bring in this chart. This particular graph is from another scholar, Julian Posada's work. So Julian is a researcher who's looked at data labeling work from a platform economy perspective and has done this in the context of Venezuela in South America. And what this graphic shows us is that since 2020, there's been a boom in the labeling work being conducted in Venezuela. But however, towards 2021, you see a dip in that kind of work being conducted in Venezuela and a shift to Kenya. And the reason I bring this up is to say that a lot of literature and in the popular press, we see uh, data labeling as being referred to work that's done predominantly in the global south. But even when we talk about this work being done in the global south, it is not uniformly sort of spread out, and there have been variations over time. And there are socioeconomic and political reasons why, at different points in time, this work peaks in different parts of the world. From Julian's work, we can learn that one of the reasons why Venezuela was seen as a prime location for data work since I think 2019 or so is because of the economic crisis there and the political climate that made Venezuelan labor very cheaply available for data work. And I thought that that's also relevant to keep in mind as we talk about the data labeling work in India and also think about what are its implications when we try and understand this a bit more globally. So, in today's talk, as I laid out in the talk description circulated earlier, I want to focus on two things. Firstly, what is it that data labelers do when they do labeling work for AI? And secondly, why should we, as AI researchers and practitioners, concern ourselves with what they do? And before I get into answering those questions, I also want to talk a bit about how I might be able to answer those questions. To talk about this, I draw on an ethnographic field study that I conducted last year in South India. So I visited the data labeling offices of a particular organization that I'll refer to as Data Futures. So Data Futures is is a company that is set up headquartered in Bangalore, and Bangalore is the IT hub in India. So the company is set up in Bangalore, but the data annotation centers that it operates is spread out across smaller towns and in some cases villages across South India. So in total they have about 5 to 6 centers spread across 3 to 4 towns. And I visited a couple of these towns and worked with people in in centers in these two towns for the purposes of this study. I spent over 160 hours doing ethnographic fieldwork over the summer. And during this time, I had the opportunity to observe 5 different projects across 7 teams. And these projects were at different stages of completion and were different also in scale and scope, as I'll show later. And during this time, I was able to interact and interview data labelers, again, folks with different levels of seniority, people in management, including senior managers and team leads. And an interesting aspect of ethnographic fieldwork is beyond conducting formal interviews and observations. It allowed me to embed myself in this environment for a reasonably extended period of time. So this meant that I was not only shadowing their day-to-day work, but also joining them for team meetings, any debriefs that team leads provided, joining them for coffee breaks, taking part in lunch table conversations, and long bus rides. And I mentioned bus rides because one of these offices was located about 2 hours away from the major town, which meant that anybody working here had to take a one-way 2 hour bus commute to get to the workplace. And it was during this time that I was able to chat particularly with the women. And as you can see from the images here, women formed a sizable part of the workforce in both these sites. And being able to spend an extended period of time in these sites allowed me to sort of build those interactions and connections through these various different moments and places. And through this, I was able to build an immersive understanding of what annotation tasks look like, what kinds of tools were used, the challenges and breakdowns that they faced, and how they sort of worked around it. So what did they do when they did annotation? Like I mentioned earlier, a preliminary understanding of annotation is that it is used towards building training data sets. But one of the things I learned through this study is the different ways in which annotation contributes to those training data sets. The most straightforward way is, of course, being given a data set and then labeling it and sort of returning it to clients. A second was what is called validating model outcomes. And I'll explain that with an example in just a moment. A third is what was called exception handling, or in literature has been referred to as AI impersonation services. That is to say that when an AI system is deployed in the real world, there is quite often a human team that is available for almost real-time support. And so when an AI system fails to provide a certain outcome to the end user, the human worker steps in to mimic the AI system so that the end user has a seamless experience at their end. And this kind of work was done in quite a few different contexts across the projects that they worked on at the time of my study. Some key examples are what was called e-commerce product matching. Here, what they did was support large corporations that were in the e-commerce business by enabling their competitor analysis. So if the platform wanted to understand how their competitor priced certain products, they first needed to know if the competitor sold the exact same product so that they could then computationally figure out what the best pricing strategy would be. And the team in South India did precisely that. For a list of about tens of thousands of products given to them each day, a team of about 1,500 labelers would spend the day identifying if the same product existed on the competitor's website. Similarly, another project was to do model validation for cab hailing apps. So this was again an AI system that did automated navigation. And one particular project at that time was what was called turn restrictions, where the model would identify where turn restrictions were on London roads. And the team here would then validate that outcome by looking at geospatial data and aerial imagery to understand whether and validate whether the model was right or wrong. Tiller shopping was another case where a startup in North America was building a tool to allow customers to walk into a physical store, a grocery store, pick up whatever they want and walk out, and they would be automatically billed. And this was possible through sensors in the store and a lot of CCTV footage. And this is where the exception handling team supported the seamless experience of the shopper to walk in, pick up what they want, and leave, and they would be rightly billed. Now, if the AI system couldn't bill them correctly, the human team would verify the bill and then make sure that they were only billed for what they chose and not for things that they didn't pick up. How did they do this? They would have access to the CCTV footage and then they would verify by following the customer through the shop. And all of these contexts were projects that made them wherein they worked with clients who were both large corporations but also startups both in the West as well as in India. And to conduct this annotation work, they used in some cases client owned tools, in other cases so third party vendors that the client would give them access to, or in a few cases also open source software. To talk about what annotation looks like, I want to focus and you bring attention to one particular practice, which is counting. And by counting, I'm referring to the practice of quantifying and numbering all of the work that annotation involved. To put it simply, counting was very integral to how annotation is carried out. Right from how many people work in a particular project, how many people are required per day, per shift for every data set, how much time did each of them take to finish a single task, to how many tasks did each of them finish over an hour, what was their accuracy rate, what is their productivity, to what are what are sort of targets that they're able to meet for the client. All of these existed as numbers, and these numbers were an integral part of how data work was organized. And I'm going to use these numbers as a way for us to understand what data work looked like. This is also based on a paper that is under review at CSEW, and I'm hoping we could also discuss and get some feedback. Firstly, like I mentioned, counting was a necessary practice within data labeling. This is a table from the checkout free shopping project, which provided near real time support through the exception handling annotation work. So, what happens is every week, the client, which is the AI startup from the West, would provide this table, particularly the first 3 rows. So, as you can see, it lists all 7 days of the week and 3 shifts. What is important to note is with a AI support team, which is this sort of exception handling work, because the AI system is deployed in the real world and in a context where shoppers could walk in and out of stores at any time, the exception handling team had to be available 24/7 all through the year. So this meant that the work was divided into 3 shifts. So morning shift worked from people in the morning shift worked from 7 a.m. to 4 p.m. The mid shift worked from 1 p.m. to 10 p.m. and the night shift worked from 10 p.m. to 7 a.m. And this was also in rotation. So if you worked the morning shift 1 month, the next month you're on the mid shift, and then the next month you're on the night shift. So what happens is every week the client would say, these are the figures, number of people I need in the shift each day, and these numbers have to be met. That is part of the agreement with the client. And as you can see here, the number of people required on a Friday night and over the weekends is usually higher than what is required in the working hours of the Indian morning shift and mid shift. And this is because it is only on Fridays and weekends that the stores where this AI is deployed sees a particularly high footfall, and therefore they need more real-time support during this period. So when the client gives this outsourcing team this table, the managers then work in the off count row. Off count row is to decide how many people are going to be on leave on each of these days, and working that into the schedule and roster for the whole project. And it'll become clear in just a moment when I show you what that looks like. So this is another table where they essentially plan who is going to be working on which day. So Devi, Kavi, Priya, and Dev are people on the team. And for each of them, for the next couple of weeks, they would be told what days they're expected to be in office and what days are the days that they can have off. Yellow here indicates the off days. And as you can see, you may have 1 or up to 2 days off a week, and you also may not always get those 2 days consecutively. And if you're really lucky, they may fall on the weekend, but that's again very rare, because as we've already seen, the weekend is when you need the most hands on deck. So this table is dependent on the first table. As soon as the client gives you the mid-morning and night shift count, that is the count that the team then keeps in mind and works in the off count into that and then plans the roster. So this roster does afford some flexibility. And this is in fact one of the ways in which this particular project is pitched to anybody that they hire, that you can swap off days if you wanted with your colleagues, so long as you don't disturb the count that the client requires. So if the client requires 42 people and you need a Wednesday off to go to the bank, sure, you just swap your off day with someone else who has an off on Wednesday, and all is well. So what I want to highlight through this example is to begin showing that counting was a very integral part of doing annotation. You couldn't do annotation without this kind of counting coming into the scene. And it wasn't just to plan the work and to plan headcount for the project. It also comes in at the end of the day when you have to report what has been accomplished on that particular day back to the client. So every day, team leads would send what is called the end of day report, or EOD, to their clients to say that this is the data set we received today. It had so many tasks, of which this is how much we finished. And to do this, we involved a team of so many annotators. And tomorrow we'll be picking up whatever is remaining. And if there are any highlights, like there was a power cut from 2 to 4, and that's why there's a dip in numbers. Or we thought we've become quite skilled at this, and that's why we've been able to achieve high productivity. All of this is worked into that EOD report and shared every evening. So as you begin to see counting as sort of an important part of how annotation is organized, it not only served to communicate how annotation is done, but it also was very much how annotation was understood, imagined, and carried out. And to illustrate that, I want to draw on a few examples. The table here shows what an AHT table looks like. AHT refers to average handling time. So average handling time, very simply put, is how long does it take to do a particular task. And if you see here, this is from the checkout free shopping project. And these are the types, some of the types of annotation tasks that the team would receive. Interaction labeling is when you map how whether a customer is picking a product or putting a product. Person matching is to verify whether the person leaving and the person who entered are identified as the same person. And check billing is if the AI system gets the billing wrong, the human is going to verify the full video of that customer and ensure that the bill is right. So for each of these tasks, there was an agreed upon time within which it had to be completed, and that's the baseline figure. You take about 5 minutes to check a person's billing, you take about a minute to do these other tasks. And as you can see in red and green, every day they would track whether this baseline could be met or not. And there were elaborate counting processes in place to come up with this table. So they had an entire team that would work on this at the end of the day, who would get the data of all the tasks that were completed on that particular day, and then calculate whether for every category of task the baseline was met or not. And it doesn't end here. Once this is calculated, they would also replicate the same for every annotator in this project. That is to say, such a table exists not just for the whole team, but for against every annotator's name. So they would be able to see whether each annotator is meeting the baseline AHT figures across each type of task. And this is just in one project. In several other projects, you see things like hourly trackers, which is to say that at the end of the day, the client wants us to finish 50,000 URLs or 50,000 tasks. So towards that, every hour we should be finishing, say, I don't know, about 800 tasks per person. And how are we doing that, on that? And to do that, they use what are called hourly trackers. And the most, I guess, striking example to show that counting was the de facto language of organizing annotation was what was called the goodwill score. So, to keep track of how annotation was progressing each day and how the annotators performed, the managers and team leads tracked both productivity and accuracy. How fast are their annotators and how accurate are their annotators, how error free they are. And then there was a third score. This third score was called the goodwill score. I asked them, what do you mean by the goodwill score? The goodwill score was to capture everything beyond accuracy and productivity. Is the annotator willing to stay back a bit longer if the client wants something extra? Is the annotators showing involvement? Are they helpful to their teammates? Are they curious about what the project reveals? Are they able to find out new patterns to make the work more easy? All of these things was a reflection of goodwill. And what knocked off points for the goodwill score? It was things like, I need an off today. I don't know, just make it happen. If they went to their TL with such requests, that meant that it would reflect poorly on their goodwill score. So the goodwill score was effectively a catch-all, the quintessential other category that clubbed everything that didn't fit in within accuracy and productivity. And to me, what was interesting is the fact that something like the goodwill score existed showed that there was a strong inclination to make everything fit into the counting language. But how did these counts arrive? So again, before I move on to that, I thought this was a excerpt that really showed again how the kind of associations made with counts. So this is a junior TL who said that I keep track of the hourly targets very closely. And if someone's done very little in the morning, then surely in the afternoon, they're going to be racing against time to finish. And that means errors are going to be more. This association that if a count drops in the morning, that errors are going to be more in the evening is again a reflection of how counting was an important way in which annotation work was understood. But the numbers with which they're working, the baseline AHT figures, were not a given. This was agreed upon between the client and our team in South India through a process called benchmarking. Benchmarking was an exercise where at the start of a new type of task, the whole team would spend about 1 hour each doing a sample of say about 100 tasks from the larger data set and say how long each of them took, and then they would average it out, send it back to the client and say from the benchmarking exercise we've identified that the average handling time is about 2 minutes, or that we could do about 60 tasks in 1 hour, and then the client has to approve it. Only after the client has approved it would they be able to proceed setting that as the target. And the interesting thing here is that the client rarely agreed with what they presented in the first go. Here, Shankar says that often clients say that based on your previous data set, we've now trained the algorithm, so it will do better now. So, which means tasks are going to be easier, and that means you need to be able to do more tasks. And this is when the client is saying that the model improvements is a reason for their expectation that the AHT should be better. In some cases, it's not as well explained. They simply emphasize that you've done your benchmarking, we've done ours, and we know that 60 is too low. You should be able to do 80. We've done the same benchmarking exercise. And this becomes harder for the team to sort of push back and explain. And in many cases, they have to accept what the client says because there are longer term implications to this. On the one hand, they are the ones who are working with the data and therefore best positioned to say how long the tasks are going to take. But on the other hand, they're also aiming to build long term relationship with these clients. In some cases, I mentioned that the project involved 100 people, or in the case of product matching, involved 1,500 people. None of those projects started at that scale. In the case of the till-less shopping, it started as a 2-member project and then slowly expanded into a 100-member team across 3 shifts by building a consistent relationship with the client. Similarly, in the e-commerce case, where they started as a team of about 15 people, which then grew into 1,500 or so today over a decade. And building those relationships were important. And an important part of that was then making compromises and asking the team to maybe extend by an hour or so that they could meet those targets, even if they weren't really reasonable at all times. But what happens when they're making these adjustments? In some cases, they go the extra mile to make the count work. But in some cases, the count just falls short. And I just want to use 2 examples here to illustrate that. On the right, you see an image generated using stable diffusion, partly because they're working with client data, so I couldn't take pictures of the data sets that they were working on. So in the till-less shopping case, an interesting example is when they do check billing. Usually it is a family that walks into the store with 2 or 3 kids, and all 3 kids run in 3 different directions because of course that's what kids do. So they're all picking different things from these different aisles and then take it back to the parent and say, I want this or that. And then the parent says, no, I'm not going to buy you any of this. So they're then forced to go drop it off at wherever they picked it up from or drop it wherever. So now when these kind of tasks come in, it's not just one person who's looking at what happens in this case. Though the cart is one, though the customer is one, which is the parent, it's involved at least 4 or 5 shoppers, and therefore there is a team of about 4 or 5 of them in the data annotation center, who sit together and then say, each of us is going to follow one kid, and then let's all congregate again after 15 minutes to decide what is it that they finally took in their hands. So there's a collaborative team effort involved in determining what one person's bill is. And there is no room in any of these counts to account for this sort of collaboration. And it's not just in the case of families and children, but also in the case of just everyday tasks, where it was very common for annotators to just peep into the next person's monitor and say, oh, maybe it's not this, oh, maybe it's not that. Or someone asking, could you tell me if I'm right? I don't want to get it wrong. But because remember, an important count here is also your accuracy. So there's a lot of collaborative work happening that the count fails to account for. And another thing is what we saw earlier with the benchmarking exercise, which is to say, how much can you do in an hour? Again, what this fails to accommodate is what happens when you do the same thing over an extended period of time. Every hour has a toll on the next hour. And the benchmarking exercise captures what happens in 1 hour, but fails to capture what happens to the same task when you do it over a repeated period of time. And that was what Kanta told me as one of the biggest challenges in negotiating with clients, that they don't see that when you do the same task over a repeatedly over a period of time, it's hard to keep delivering the same count. And accounting for these long term experiences was something granular counts failed at, because they were inherently better at getting more and more granular, but but did not have the same ability to zoom out and look at the sort of bigger picture. So what do we see through these cases of counting as a necessary practice, as a with negotiating as the de facto language and with it falling short? We see that numbers are adopted as sort of this neutral entity, and that counting was a almost inevitable, just rigorous methodological choice that they were making to organize and data annotation. But through this study, we see that that's not the case at all. We see a subordination in counts happening. For instance, in the roster planning, what is sacrosanct is the table that the client gives, that no matter what, every shift had to have the number of people stated in it. Within that number, you could then accommodate people's leaves, but it was very much subordinated to the client's expected count. Similarly, you could swap as a annotator yourself. You could swap the days you wanted off. But once again, as long as you don't disturb the bigger count, which is the client's mandate. Besides that subordination, you also see impositions. This is most explicit in the case of benchmarking, when you have clients pushing back against what is possible. And I think what is important to remember here is annotators are often the only ones who are looking at what the data set really is. And yet it is the clients who are able to impose a target figure for the annotators to work with. So we see that counting and its logic allows for a certain authority to be exerted among a few actors, and it also allows to establish conformity across the board. And it's also useful to see here, and here we draw on the sociology of quantification to show how counting does not just represent a reality, but in fact creates a clearing. And what I mean by that is, if we were to look at the complex reality of data annotation and the real worlds that they in fact label and annotate, we see that if we were to use the analogy of a forest, counting then creates a neat clearing where you bring a sample to understand the forest. We might ask, so what? So what if we're looking at a clearing? As long as it's representative, it should be okay. But that's where the trouble is. When we through this, we see that it's clearly not representative of the work that they do. And more importantly, any challenge to the count must also be defined within that vocabulary. If you're contesting benchmarking figures, you're still pushing against a number using a different number, but you cannot escape the numbering logic altogether. And this has important implications not just for annotation, but also for AI system building. And I want to use just a couple of examples to make that point. When I talked about falling short, there's also a third case where annotators because of the pressures of maintaining a high accuracy, do what is called a skip task. A skip task is when you get a complex task, you have the option of skipping it in order to save time and in order to avoid risking an error. And annotators typically chose that when they got ambiguous tasks, when it's not always clear whether their verdict is going to be right or wrong. And this was an example where the imposition of accounting logic really led to a loss of a good opportunity to engage with ambitious tasks and ambiguous tasks, and also make the model and the AI system a better and more enriching one. We see a lost opportunity here to improve the AI system as a whole. And this is where we begin to see the implications of what the adoption of accounting as a logic means for the AI system that is at the end of all of this. And it's not just in annotation that we see this, we also see this in the case of how we're seeing efforts to improve AI systems as well. For example, there have been a lot of efforts to, well-intentioned efforts to address issues of fairness, biases, and diversity within annotation and AI. And in the context of annotation, there have been quite a few studies recently that have tried to make AI systems better by having a more diverse annotator pool. But what this study shows us is that efforts to fix that cannot be an afterthought. When we've already foreclosed the possibility to engage with ambiguous tasks, when we've already foreclosed the possibility to engage with long-term effects and the realities of collaboration, and restricted what an annotator is able to do within this counting logic, then many of these efforts towards fairness or diversity, however well-intentioned, become very limited in their impact. So it's very important that we move from thinking about what retroactive fixes can be to confronting the structural logics that are in operation. And I wanted to finish the talk with this image. This is an image of the keyboard at the product matching site. In that center, most of the keyboards look like this. Now, what is interesting about the keyboard is that the letters C, V, and S and Control are nearly erased. And in many other keyboards, they were completely erased. This was a trainee's keyboard. And the reason they're erased is because they're doing 1,500 tasks a day just using these four keys. And this is the reality of counting. And I thought this is a useful visual image for us to keep in mind as we think about what adopting the logic of counting to annotation means. Thank you.
Thank you. Thank you very much, Shravya, for quite an insightful talk. We have a number of questions in the chat. Let me just read them for you. So Patrick is asking, could you talk about how human errors in this task are identified and by whom with an example?
Yeah, I'm just looking into that.
Yeah, sure.
Cool. How human errors in these tasks are identified and by whom with an example. Let's see. So human errors in labeling work through a process called, they have a multi-level process of checking. And here what they do is, for instance, in the product matching project, they have 5 levels of check. So once an entry-level annotator finishes the task, it goes on to what is called a quality analysis person. So this person will redo the same task to verify if both the verdicts are the same. Now, if it is same, it's then accepted. If not, it goes to a third person called the quality control person. This is an even more senior person with more experience who asks what is the reason that the two tasks are, the two verdicts are different, and then they try and resolve that. So this is already 3 levels. Once these 3 levels are over, there's a fourth level which verifies about 20% of the tasks that have been passed through these 3 levels. And then finally, there's what is called the rapid action team, which does a random check. So there are different levels of accuracy checks that work. at depending on the scale of the project. And in this case, it's about 5 levels. I hope that answers that.
Yes, it does. Thanks.
Yeah.
Another one from Jackie. Do you want to read it or should I?
Yeah, I can read it.
Yes.
It begs the question, what's the point of these shops? If you remove the person serving at the till for someone checking the AI instead, especially given that there must be people working in these shops behind the scenes to stack and so on, uh, this seems like a bit of a societally non-beneficial AI. Yeah, I think that's an excellent point. And I did, in fact, ask the managers at the site, how come that if the idea here is to remove and save money by removing 3 people at the checkout counter, uh, you are already 100 people here. How does this add up? And he said it's not always about saving money alone. And in this case, there might be a factor of customer delight. He said that the customer is always looking for novelty in any experience, and that is how the company sells it. The company is not selling it to stores by saying that you can get rid of 3 employees, but instead that your customers are going to be delighted, and that's how this industry seems to work. And they themselves had limited insight into it because they are not the ones who are marketing or involved in the interactions with people who use it, but this was their guess, and this is what their client had told him. But I completely agree that its benefits are highly debatable. Wouldn't the goal eventually be that AI would be good enough that you no longer need to check it? Yeah, I think that's a very interesting point, and I'm glad you bring it up. To make so what we see through all of these projects is that the need for the human rarely ever goes away. And in the book Ghost Work, Mary Gray and Siddharth Suri have a very good term for this. They call it the paradox of AI automation's last mile. What they mean is that whenever a particular automation target is reached, you move the goalpost and say, let's try and do this. And a very easy example for this is with computer vision. Initially, say the goal was to identify, is this a cat or a dog? And then you move on to say, can I identify everything else in the image? And then you move on to say things like video. And then you move on to more and more complex targets. And we see the same in the case of the Tillis shopping project. Initially, it was only to say that, hey, we just want you to verify bills. And then now that we have a team of 100 people, can you also check whether the person entering is the same as the person exiting? And so on and so forth. So there's always uh, an endless list of things that the AI needs in order to be able to function well. And I would also like to get a sense from you about how the annotators felt about their jobs, what was good, what was bad, etc. Yeah, that is, yeah, I think that's a very important question. And that's what I'm trying to grapple with right now in a second piece of writing that I'm doing. This company was what you called an impact sourcing company. Impact sourcing is the idea that you outsource work to communities that can benefit from having employment. So in this case, the narrative was that we are generating employment for the people in smaller towns and villages in India. And what was good and bad according to the employees, I think for them, many of them were first generation office workers. Their parents in one town came mostly from the weaving community, and even in the other case, came from dairy production and other small scale businesses. So for them, there was a lot of pride associated with being able to do IT work. For me, one of the interesting things was there's no talk about AI here. As far as they're concerned, this is IT work. This is work like what you would do in Bangalore, and you get to do it right here. That was how the company also sold it, and that was a very real benefit for the people who did it. But they were also very acutely aware that the conditions of work, including the pay, were not fair, and they definitely there was a lot of displeasure and unmet expectations in the case of how they were being paid and the number of hours they had to work. And in one interesting case, there was a female employee who was wrapping up work at the company the last week of my field visit as well. And she said, I've asked for an experience letter, not for 2 years, which is what she had worked there for, but for 1 year. If you work for 2 years, why do you want an experience letter for 1 year? And she said, with 2 years, I cannot show enough learning to apply to my next job and say I've done this for 2 years, but I know nothing at the end of 2 years. At least if I show I've done this only for 1 year, they'll take me in as a fresher in my next job. So these are real compromises they're making in order to make do with what they can get out of this job.
Thank you. That was very insightful.
And I can only see it mostly as a way to increase profits. Yes, that is, I think, definitely a part of the equation. And one of the things I'm interested in going forward is to also understand how funding for some of these projects work, for some of these AI products and services work, in order to sort of piece this puzzle together. Stephanie says, indeed makes me think this is merely the retail industry's version of moving jobs from the north to the south, as it happened in manufacturing industry decades ago. Absolutely, yeah. Pratik says, while it isn't a benefit to society, the motivation here might be speed and efficiency. I've shopped at Amazon Go multiple times before, and the shopping experience is devoid of any human interaction whatsoever. You go in, pick up, and leave. You send a bill and debit it directly. Yeah, it is the convenience that is sold to the customer. When ChatGPT was announced, we learned the dark side of data annotation. The annotators were exposed to disturbing content and very low pay. What measures are being taken in the industry to protect data annotators given their importance in AI? Yeah, I think I'm going to spend quite a bit of time on that because there's a lot to unpack here. I think and this is something other researchers working on tech and labor have also pointed out in recent years. Um, a lot of journalistic pieces have sort of exposed this sort of dark underbelly of AI, that there are all of these thousands of workers who are working in all of these faraway places doing data annotation work. And the problem with that is saying, it reduces them to this dark, sort of undesirable secret, which takes away the importance of the work that they do. Secondly, it also undermines the expertise that they bring to the table. A lot of them being able to, data labeling work is by the day becoming more and more expert driven, and it needs years of experience for you to be able to annotate in some context. And reducing it to, oh, then they're all doing this labeling work that is fully monotonous. Yes, it's monotonous, and I struggle with sort of balancing this monotony versus expertise, but in some cases I also feel it can be reductive. But for me, the biggest problem is also how it is used to say that all of this is hidden work. In some cases it's not hidden at all. In the places that I visited, this is work that is carried out with a lot of pride, especially to communicate it to their families, to say that I'm doing IT work, I sit in an AC office, things that the family could never have imagined one generation ago. So the visibility, the overemphasis on visibility has already been pointed out as insufficient, and however well intentioned, does not really work does not center the experiences of the people who do this work. And what measures are being taken in the industry? In some companies there are efforts such as mental health support. So you have counseling and therapy services that are available to people who work on sensitive content. But again, this is not industry wide, this is not regulated, and this is not mandated across the board. This is subject to just the goodwill of independent companies doing it on their own accord. And in some cases, they also choose not to take on projects like sort of content moderation. But again, those are independent choices each company is making. Yeah. I think this is very similar to Amazon Go, what I just explained. And it's fascinating how the other fascinating thing for me was what gets called an exception. Children running around the store is the norm. It's rarely the exception. So because the AI system cannot make sense of a family of 4 people spreading out into a store, the norm becomes an exception. And I feel like there's something to unpack there as well.
Thank you. Thank you so much for answering our questions, Ravia. That was really great. Do you still have questions for us, Ravia? Please feel free to unmute and just ask. We still have 5 more minutes. Yeah, thank you. Thank you, everybody is clapping. Any questions for us, Ravia? Please feel free to unmute and just ask. Great. I think I think we are good. Thank you for such a insightful and quite informative talk, Shravya. It was really great. I enjoyed the session. You wonderfully answered the questions. I mean, thank you very, very much. And for everybody, thank you so much for joining. And we'll keep you updated about our next session.
Thank you so
Sorry.
much for having me here. It was my pleasure. And thinking about these questions is also useful for me as I work and revise this paper as well. Thanks for having me here today. This has been a great experience for me too.
Thank you for joining us. So thank you. Bye, everybody.
Bye-bye.